Hey Cleveland fans, we're back here with a couple blocks. I know I said my next video would be on the oiling system, and we have done part of that video, but some of my drawings didn't come out quite so clear, so we got to redo those. But this one will be a real quick video about a question that we were asked the other day after some other information was posted out there on the internet. And what we were asked the question was about main bolts. Apparently there was some information out there about studs and bolts and materials and that sort of thing, so we wanted to make some things clear and let you know that this just isn't something that happens by accident. It's something that a lot of thought actually went into to get where we are. Anyhow, what we were asked about the other day was made mention of using a stud and replacing the fasteners in a block that already have bolts in it with studs, or using something else other than was supplied with the block. And that information was what I feel to be probably partially true, which is you should always check whenever you replace a fastener. You should always check to make sure that it stresses the block and does things the same to the block as what it had been done before. We put the fasteners in the block, we torque them to our spec before we line bore and we line home these blocks. And we think that probably everybody else that makes blocks or actually does machine work pretty much does it the same way. Anyhow, there was apparently some ambiguity also of why we use a particular screw that we do. This is the screw that we actually use in our block. I'll stand over here. We actually relocated the fasteners on a Titus block so that there's more thread engagement on the thread than what we could get with you leaving it in the standard position. And the reason that we use this particular bolt is because this particular bolt has a longer thread than what we can usually find standardized in the industry. And what we wanted to use is we wanted to use a bolt that could be replaced at an economical price. It didn't have to be custom made, just for our particular block or anything like that. But we do have our block designed to where we can use this whole thread. Now, we got down to materials. There was some ambiguity about 8740, 4340 strength of materials. This is a 4340 bolt. It is an American-made bolt, and it has 190,000 psi minimum shear strength. And that's what you're looking at, is you want to look at the minimum shear strength. We did a little bit of looking out on the net too, and we also saw that some of the information that was posted out there about the studs that were in question on some blocks. We saw that their reports noted that there was, when the stud did fail, which it looked to be a very good stud, when the stud did fail, the stud actually failed on the threads, which is what one would expect. It is the smallest point of cross-sectional area of the bolt. So let me just draw a few things here that we want to show sort of as what goes into a little bit of engineering. And for those who just use plain old common sense like I like to do. If you're looking at a particular fastener and it has threads, and we determine that the fastener will fail at the threads, which I think those test results did verify that those fasteners did fail at the threads. What we're going to see is two things. When you torque a fastener, basically what you're doing is you're trying to make it like a rubber band. You're trying to bring everything together, and it's supposed to make the fastener like elastic so that it acts as its own locker. Well, in order for a fastener to have threads and be useful, it also has to go into a part. So, if we look at this thread, this bolt is made out of 4340 steel, or this particular fastener, whether it be a stud or a bolt. If we look at this bolt at 4340 steel, and then we look what it's actually screwed into, if the threads on this particular stud were to fail first, as part of just the stud tested alone, common sense would probably tell us that any kind of failure point is going to be within this particular area, because we've already tested that determined that the stud did not fail, the threads on the stud failed. However, no matter whose block or what block you're using, you're either threading this into, if you want to go all the way up to CGI, you want to go to 40K cast iron or in aluminum, 4340 has a stronger PSI than what all of those other materials do. So the weak point of any of these fasteners is not going to be the fastener itself, it's going to be the material that it's screwed into. Now, if we want to look at some other deals, what we did with the Titus block was we machined the block to where we could actually, and relocated the fasteners to where we could run our fastener deeper down into the block. So instead of having a fastener that comes down here, we run our fastener down deeper, and we use a special fastener that has more threads on it. Reason being, more threads, more strength. Now if you take a block and put a stud in it that doesn't have as much thread engagement, and you countersink the top of the block so that you can use a fat part of this stud to so-called center this, well, now you've actually, not only do you have the short threads, but you've taken some threads away. So while you can have all the material in the world, you can make this thing out of kryptonite, Superman's head, or whatever you want to make it out of, it's still going to be the weak point, is going to be the material that you actually screw it into. Now another point that was brought up was about replacing fasteners after they've been put into the block, and it was properly said that you may or may not choose to replace these fasteners. What we also saw in the next video that was put out by folks that have words about fasteners, well, here's what I wanted to show with a torque plate, since we have a video with the block being honed. The block that was being honed used a bolt, guess what, an Allen head cap screw, to bolt the torque plate down to the block. Now, we believe in equal treatment for the top of the block as to the bottom of the block. So if we're going to take the bottom of the block and say that if we have to take the fasteners out and replace a new one, that you may have to realign hone the block, well, maybe you do have a block that moves all around, maybe you don't. But if you're going to have that same attention to the bottom of the block, then you probably should have the same attention to the top of the block. So while you have a choice to replace these fasteners in the bottom of the block, you don't have the choice to use this fastener to bolt your head onto the block. It's kind of short and won't fit. We also don't know what the thread engagement length is. So the proper way, the way we actually do a block in-house, is we use the stud or the fastener that is going to get used on the head. And here we have some regular Cleveland heads. This is an aftermarket Yates style stud. We use the studs, we put the studs in the block. We screw those all the way in, we bottom the studs out just like we're going to put a head on. Then once we have our stud in the block, which this is not going to fit the way I have it sitting on the cart, then we take our box of handy dandy spacers that I've made over the last 25 years, and we use all these spacers and we make up the difference. So when we're torquing the block, yes, we actually do torque the block and we hone the block with the head stud or fastener that's going to be used in the block to get as close as we can. So if we're going to have that particular attention to detail here, that maybe we should realign hone the block, maybe they should use the same attention to detail when they hone the top of the block. Bottom line, guys, is as a mechanical engineer, and yes, engineers get a bad rap a lot of times for going off into the obscure and talking theory and this and that and the other. That's why I'm trying to actually do these videos and bring you things that show you that a lot of engineering is just plain common sense. Now when we can get into strength of materials and yield points and elongation and all the other high-tech terms of engineering that we don't really need to get into, the first thing that they tell you in engineering school or teach you in engineering school is whenever you're going to perform an experiment, and sometimes what we do is machining blocks and putting together engines. Let's face it, sometimes they're experiments. But the first thing that they tell you to do is do your experiments consistently. If you're going to perform an experiment and you change the variables with the experiment, you have no idea when your changes are come around and you record your changes, you have no idea what caused the change. Was it this? Was it this? Or was it just the procedure within itself? Who knows? Look at what's out there Pay attention to what you're looking at. Pay attention to what you hear, and also use common sense.